Good day, students. So in this clip, we're going to be going over 4 examples on how to solve exponential equations using common logarithms, okay? So first of all, what are common logarithms? Common logarithms are simply logarithms with a base of 10, okay? So common logs are logs with a base of 10, right? For example, log of 5 is a common logarithm. Why is that? Because it doesn't have a base. So if there isn't any base included, the default base is base 10, okay? So if you see any logarithm without a base, you just automatically know that the base is base 10, okay? So that's known as common logarithm. Now, one thing about common logarithm is the fact that most calculators have a common log. So if you want to find the approximate value of a logarithmic expression, um, it's good to have it expressed in common logarithmic form. Okay, so let's say you have log. If you wanted to find the approximate value of log base 2 of 3, for instance, let me show you a calculator. I'm going to show you a TI-83. If you take a look at this TI-83 calculator, you notice that we do not have, it doesn't have any common log, it doesn't have any log base 2 on it, okay, but it has that log there. So in order to be able to find the approximate value of this, I need to express this log base 2 as a common log, or namely log base 10, all right? So to do that, I'll use a method called the change of base formula. So this basically becomes log base 10 of 3, log base 10 of 3. I can just, yeah, let me write it like that first. Log base 10 of 3 divided by log base 10 of 2. Okay. So what on earth is log base 10 of 3? Well, this is a common log, and this is also a common log. Remember, the rule of thumb is if the base is 10, you need not write the base. Okay, so this is basically log 3 divided by log 2. Okay, and guess what? This can be inputted into a calculator with ease, and we can find the approximate value of this original logarithmic expression. So we're just going to go log 3 divided by log 2. You notice in the calculator that there isn't any base. That basically means it's a common log, and the base is 10. All right, so the approximate value is 1.5849. So this is approximately 1.5849. Now, when do we use common logarithms? Well, common logarithms can be used to solve basically any exponential equation, but the main application is for exponential equations with unlike bases, okay? So used mainly for exponential equations with unlike bases. All right, let me give you an example. Take a look at this, for instance. If I wanted to solve this equation, 3 to the x equals 3 squared. The bases are the same, right? So I can simply go log base 3 of 3 to the x equals log base 3 of 3 squared. So you notice these are inverses, they cancel out. I'll have x equals, and these are inverses, they cancel out, so it equals 2. So I have an exact answer here. I did not have to use a common logarithm, okay, because the bases are identical. Now, what if I have a scenario where you have 2 to the x equals 5 squared? All right, let me take log base 2 of both sides because the base of the exponent on the left is 2. So what if I go log base 2 of 2 to the x on the left side, and then log base 2 of 5 squared? Okay. You notice on the left side, these two cancel out, and you're just left with x equals, now I can power this 2 down, equals 2 log base 2 of 5. All right. Now I cannot plug this into my calculator if I want to find the approximate value. So what do I have to do? I have to do a change of base, right? So this basically becomes 2 log base 5 divided by log base 2. Now I can plug this in my calculator and find an approximate result. But what if I didn't know my change of base formula? I'll get stuck, right? So using common logarithm requires you not to have the change of base formula memorized. So this is one method of doing this. Let me show you the same procedure using common log to help you see why it's good to know the whole idea of common logarithms. Okay, so I have the same equation, 2 to the x equals 5 square. I'm going to take the common log of both sides, log base 2 to the x and log base 5 square. I'm going to power down both exponents. I'm going to have x log base log 2 equals 2 log 5. To get x by itself, I divide both sides by log 2. And my answer will be x equals 2 log 5 over log 2. Got exactly the same answer, but we didn't have to apply a change of base formula here. So since I have this as a common log, I can plug it into my calculator and get the approximate result. Okay, so let me just enter that real quick, and then we'll go ahead and get started with the examples for today. So we have 2 log 5 divided by log 2. All right, and then your answer is 4.6439. So it's approximately 4.6439. All right, so that goes the main reason for knowing how to use common logarithms. All right, let's go ahead and take a look at the following examples. So these are the instructions for the examples. Solve the following log equations and find the approximate value of your results. All right, so with that in mind, let's take a look at question number 1. What if I had equation 3 to the x equals 15? There's no way I can express 15 as a power of 3, so it's clear here that the bases are dissimilar, so we have to use common logs, okay? So what I'll do is I'll take the log of the left side, log of 3x. Remember, the default base for common logarithm is 10. You don't have to put it, okay? And on the right side, log of 15. All right, now I can power down the exponent on the left side using the power property of logarithms. This x can come down. So that's going to leave me with x log 3 equals log 15. Now to get x by itself, I can divide both sides by log 3. So divide the left by log 3 and divide the right by log 3. And then you have your exact answer as log 15 divided by log 3. Okay? You got to be careful here. You can't divide this. Remember, logarithm, this is an input of the logarithmic function. You have to take the log first of these two before you divide, so you can't divide this. Instructions calls for an approximate value, so we have to input this expression into our calculator to determine the approximate value of log 15 over log 3. All right, so let's do it. We're going to do log 15 divided by log 3. And final answer is 2.465. So our approximate answer for question number 1 is 2.465. All right, so there you have it. All right, now let's move along to question number 2. So for question 2, we have the log equation 6 to the x plus 2 equals 5.3. Currently the bases are different here, so we're going to use common log to solve it. So we're going to take the common log of both sides. So on the left side, we're going to take the common log, or log base 10 of 6 to the x plus 2 equals, on the right side, the common log of 5.3, or log base 10 of 5.3. Remember, you do not write down the bases. Okay, now I can power down this expression right here, this quantity. can power down using the power property of logarithms. So I have x plus 2 times log, the common log of 6 equals the common log of 5.3. Now, next thing I'm going to do is this, let's see. We can divide by log 6.2 and then subtract 2, or we can distribute, subtract, and divide. So let's divide first. Whichever way we use, we're going to get the same answer. But let's just divide first. Divide both sides by log 6, the common log of 6. All right, on the left side, you notice that these two divide out to 1. That leaves us with x plus 2 equals the common log of 5.3 divided by the common log of 6. So we'll now just subtract 2 from both sides. That yields the exact answer, which is the common log of 5.3 over the common log of 6 minus 2. Okay, this is the exact answer, the approximate answer. We're going to input this into our calculators and see what we get. All right, so we're going to do log 5.3. Be sure to close the parentheses so you don't have a grouping error, divided by log 6, and then we subtract 2 from the whole thing. And your final answer is negative 1.069. Negative 1.0692. So negative 1.0692 is your approximate result. So there goes your answer for question number 2. All right, let's move on to number 3. What if we have the log equation, 3 to the x equals, 3 to the x plus 1, 3 to the x plus 1 equals 5 to the x. X's are clearly different here, so I'm going to take the common log of both sides, okay? Another thing to note is taking common log and the natural log is very, very similar. It's exactly the same thing, okay? Also, you notice that in your calculator, you also have the natural log. So if you all these problems I've been doing, if I've taken the natural log, I'll get exactly the same answer. So you have two options to pick, either the common log or the natural log. They serve exactly the same purpose. Okay. All right. So with that in mind, I'm going to take the common log of both sides. So log of 3 to the x plus 1 equals, on the right side, log of 5 to the x. Okay. All right. Now, on the left side, I'm going to power down the exponent, which is the quantity x plus 1. And on the right side, I'm going to power the exponent, which is x. So I'm going to have x plus 1 quantity times log of 3, the common log of 3, equals x times the log of 5. Okay. All right. This problem is a little bit interesting because we have an x here. So well, what I can do, just to make things simple, there are two ways of doing this, but the way I'm going to do this, I'm going to distribute this log of 3 to these two quantities right here. So if I do that distribution, you're going to have x log 3 plus log 3 equals x log 5. The reason I distribute it is I want to collect all the x terms with x's to one side and everything on the other side, okay? So how about I move x log 3 to the right, since there's a log with an x coefficient on the right. So I'll just subtract x log 3 from both sides. So that's going to leave me with log 3. Now we can't combine these since the logarithmic values are different. So we're going to write this as x log 5 minus x log 3. What I'm going to do is I'm going to factor out an x from these two terms on the right. Okay, so I have log 3 equals x times log 5 minus log 3. Okay. All right. So lastly, what I'm going to do is to isolate x. I'll divide both sides. I'll divide both sides by log 5 minus 3. log 5 minus log 3. And on the right side, I'll also divide by log 5 minus log 3. Okay? So this divide out, and then we can write this as x equals log 3 divided by log 5 minus log 3. Okay? To find the approximate value of this, we just simply plug this into our calculators. Log 3. Now, since I have two terms in the denominator, I have to be careful to encapsulate them in the parentheses, okay? So open the parentheses that starts the denominator with more than one term, log 5 minus log 3. Now, if there's only one term in the denominator, there's no need for grouping it with the parentheses, right? But since you have more than one term, you always have to group them, or else the other term will be sent to the numerator. It will be assumed to be something you're subtracting this quotient from, okay? So be really careful with the grouping when you're dealing with denominators. So our answer is 2.1507, 2.1507, approximately 2.1507. All right, so there goes your result. All right. All right, let's move on to question number 4, the last one. So on question 4, we have the log expression cube root of the quantity of 2 with the exponent 2 to the 6x plus 3 equals 3 to the x. Okay, so this one's a little bit long, not too complicated, but let's go ahead and try it out. All right, so in order to take the log of both sides, I need both of the terms on both sides to be expressed as exponents. So this one on the left side requires some work. Okay, so what I'm going to do first is I'm going to use the end property of exponents to express this radical as a power, as a rational exponent. Okay, so to do that, I'm going to write this as 2 to the 6x plus 3. This whole thing will be raised to the 1/3 power. All right, that's the nth root property of exponents that I'm applying here. Now, this stays the same as 3 to the x. Now, using the power of a power property, I'm going to distribute this power to this power in here. Okay, so this 1/3 will be going to will be multiplied by this. Okay, so to save time, I can just simply distribute this 1/3 to this term right here and to that term right there. Okay, so what we're going to have, 2 raised to the 6x over 3 plus 3 over 3. Okay, equals 3 to the x. If I simplify the powers, I'll end up with 2 raised to the 2x plus 1 equals 3 to the x. Okay, now I have exponents on both sides, which look good, but since bases are different, we have to use the common logarithm. Okay, so we're going to take the common logarithm on both sides. On the left, I'm going to take the log, base 10 or the common log of 2 raised to the 2x plus 1. And then on the right side, the same thing, I'm going to take the log, base 10 or the common log of 3 to the x. All right, so on the left side, I can power down this exponent. So it becomes the quantity 2x plus 1 times log, the common log of 2 equals, I can also power the x on the right side, x log 3. Okay, now since I have a variable on both sides, I have to collect like terms, okay? But this x is in the parentheses here, so what I have to do on the left side is distribute first, and then I can collect my like terms, all right? So distribute log 2 to both terms in the parentheses. So we're going to have 2x log 2 plus log 2 equal x log 3. Now I want to collect all my logarithms with x coefficients to one side, so let me move them to the right side. Okay, so what I'm going to do is I'm going to subtract 2x log 2 from both sides, since there's already an x log base over here. So subtract 2x log 2. I cannot combine it with this because they have different logarithmic arguments. All right. So these ones add to 0. So these ones add up to 0. And then on the right side, I'm going to be left with log 2 equals x log 3 minus 2x log 2. Okay. Now on the right side, I'll factor out an x and then isolate the x by division. All right. So I'm going to have log 2 equals x times log 3 minus 2 log 2. Okay. Now to isolate my x, I'll divide both sides by this quantity in the parentheses. I'm going to divide by log 3 minus 2 log 2 on the right, and then on the left side, divide by log 3 minus 2 log 2. So this divides out to 1. This goes here 1, this goes here 1. So you're going to be left with x equals log 2 divided by log 3 minus 2 log 2. Okay, so that's the exact form of the answer, but the instructions require us to express our results in an approximate form. So we're going to put that into a calculator and see what the approximate value of that expression is. Okay, so let's do it. I'm going to go log 2 divided by, now we have multiple terms in our parentheses, so we have to group them together in the parentheses. So parentheses log 3 minus 2 log 2. Close the log, close the denominator, enter. Your approximate answer is negative 2.4094. Okay, negative 2.44094. So there goes the approximate solution to our original logarithmic equation. Okay, so there you have it. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel by clicking up here. More videos can be found on mydirectsurf.com. Thanks again and have a wonderful day.